Hello, this is Mr. Ware. This video will teach you the scientific ways of thinking about electricity, magnetism, and electromagnetism. Let's start with electricity. To understand electricity, we first need to understand a little bit about matter. All atoms are made of protons, neutrons, and electrons. Protons have a positive charge, neutrons have no charge, and electrons have a negative charge. Electrons are very small and can be moved between atoms. Protons are much bigger and can never move between atoms. Friction can cause the atoms in one object to lose its electrons to atoms from another object. One object will become positively charged, and the other object will become negatively charged. Static electricity is the imbalance of positive and negative charge between objects. Sometimes static electricity can suddenly discharge. Lightning is when the negative charge, or electrons in a cloud, suddenly discharges to the ground, which has a positive charge relative to the clouds. Current is the flow of electrons. Any flowing form of electrons is current. Current is what powers our lights. Charged particles create a field. These fields are called electric fields. Any particles that enter the field of another particle will feel forces. The forces felt are like gravity, but they are not gravity. A negative charge that enters the field of another negative charge will feel a force that repels it away. Opposites attract. A positive charge that enters the field of a negative charge will feel an attracting force. Electric fields flow from the positive to the negative charge. There is another type of field called magnetic fields. Magnetic fields act similarly to electric fields, except magnetic fields come from magnets instead of charged particles. A magnet is usually an ore or metal that has a north and south pole. Magnetic fields flow from the north pole to the south pole. Magnets can attract and repel other magnets. Domains are what makes an object magnetic. Domains are regions inside all magnetic and non-magnetic objects. The object is a magnet if all domains are lined up. If all domains are not lined up, then the object will not be a magnet. Magnets are attracted to metal, but not all metals. Iron is attracted to a magnet, but aluminum is not. Some objects, like an iron nail, can become magnetized by using a magnet to line up the domains. However, the domains are not permanently lined up in a nail. The domains will become disorganized if you drop the nail, resulting in the nail losing its magnetism. Electricity can create magnets. An electromagnet is one way electricity is used to create a magnet. An electromagnet is a metal core made into a magnet by an electric current passing through a wire coil surrounding it. One common example of an electromagnet is a nail connected to a battery by a wire coil. Current flows through the wire coil when it is connected to the positive and negative end of the battery. A magnetic field is produced from the wire coil when the current is flowing. The magnetic fields from the wire coil line up the domains in the nail, creating a magnet. An electromagnet loses its magnetism when the current is turned off. The wire coil will no longer produce a magnetic field when the battery runs out of power. There is no magnetic field to keep the domains in the nail lined up. If you remove the nail from the coil, it will remain magnetic until the domains are misaligned by an outside force, such as dropping the nail. Magnets can also create electricity. A generator is one way magnets can create electricity. Magnetic fields can interact with electrons. A generator uses a magnetic field to pull and push electrons in a metal to create a current. Metals, like copper, have electrons that are moved easily. That's why copper wire is often used as a pathway for current. If a magnetic field is moved across a copper wire, an electric current is made. A changing magnetic field can create an alternating current. The electrons are alternating backward and forward in direction as the magnetic field is moved up and down across the wire. Alternating current is a type of electricity in a wall socket.